Hi, my name is Ademola Iberunke, and this is a presentation on using convolutional neural network to classify and predict concrete cracks. So, by way of introduction, CNN model architecture is in four major layers: the convolution and activation layer, the pooling layer, the flattening layer, as well as the dense neural network layer. So, these first three layers, the convolution, the pooling, and the flattening layer, are generally regarded as the feature detection and feature extraction layers, while the dense neural network is considered the classification layer. So at the convolution layer, convolution operations are performed on gridded images to detect features and create feature maps using filters. At that same layer, activation function helps to helps the model helps to make the model non-linear by replacing negative values with zero within the feature map, and this helps to speed up the training of the model. And the pooling layer aggregates of filters are performed, or filters are aggregated, dimensions reduced, and new reduced feature maps are created for the next layer using strides, and this helps to reduce overfitting of the model. At the flattening layer, the multi-dimensional features or arrays are flattened or compressed into single-dimensional arrays before the data is passed into the neural network. Like I said earlier, the neural network helps to classify, um, the data. Now, this project is based on 458 cracked and uncracked concrete road images. And to perform this classification and prediction, the necessary libraries were imported. Three major folders were created for each for training, validation, and the testing data sets. The training data set was about 36% of the entire data set. The validation data set was about 30%, while the testing data set is about 34%. The images were then scaled or normalized. The batch size for the model was specified as 32. Image size was specified as 256 by 256. The training generator was specified, as well as the validation data generator, and the binary activation was specified to signify that there are two classes of output for the model, which are the cracked and uncracked concrete roads. So as I said earlier, the CNN model architecture comprises of convolution pooling. In this case, max pooling is used. These layers can be repeated as many times as necessary or as designed. And in this case, where it's repeated 3 times. And so the convolution layer was specified with a hyperparameter of 16 filters and a size of 3 by 3. The activation layer was also specified. The pooling layer helps to downsize the output of the convolution layer by taking maximum value from each 2 by 2 patch. The flattening layer flattens out, the output of the max pooling into one-dimensional array, and the fully connected dense layer of 512 was specified for classification, and the final dense layer was specified with an output layer of 1 neuron. To compile the model, a loss function of binary cross entropy was specified. The optimizer Adam was specified, as well as a matrix of accuracy. The model was trained on the training dataset with epoch of 20, as well as a validation dataset. This produced a validation accuracy of about 94%, and the test accuracy was about test accuracy on the test dataset was about 94%. To further, test the accuracy of the model, a separate image was introduced to the model to see if it's going to. This is the image right here. So the model was that image was introduced to the model to see if it's going to predict it to see how accurately it's going to predict it, and it showed it predicted the image to be cracked. Now, typically, a CNN model is trained on images that range up to tens of thousands. But because this project was based on a data set that is less than 500, I was curious to see how a pre-trained model will perform in comparison. And so the VGG16 model was used as a comparison. The VGG16 model is a 16-layer deep neural network that was introduced by some researchers from the University of Oxford. And so the necessary libraries were imported, as well as the training data set, the same, it was split as the API sequential model. The data set was also scaled. The training, validation, and testing data set were specified with their batch, with the hyperparameters. The input and the output layer so the layer in this input layer for this VGG was being pre-trained, and so the hyperparameters was also specified, and this is a summary of the VGG model with its hyperparameters. And so the model was also trained on the so it was compiled. The model was compiled with a categorical cross entropy, which is usually used for multi-dimensional classifications, but in this case, it's being used for a binary classification. Accuracy was set as the metric accuracy was specified as well, and the training produced accuracy validation accuracy of 96%. And a test accuracy of 93%, which is slightly higher than the sequential model output. Similarly, the model, the VGG16 model, was shown a separate image to see if it's going to predict correctly, and it predicted that correctly as well. So my references for this project was from the TensorFlow website, the Cargo website, and a video on YouTube. Thank you for watching.